Welcome back, Algebra 3. We are in Lesson 26. We're going to talk a little bit about logarithms. I know y'all love that subject. We kind of did a little bit of it last year. We didn't spend tons of time on it, but let's get a little bit of a refresher in our head. So a logarithm is just another form. See if I can actually spell it. Yeah, logarithm. That ITHM always kind of throws me for a loop because you don't expect those to go together. Logarithm is equal to an exponential form. It's an exponent. And an exponent is just another way to write a logarithm. We're just used to seeing the exponential form because it's just easier to do mental math with. The logarithm takes a little bit more evaluation, a little bit more time to break it down. But here's the basic format. A logarithm is written log of the base is the number with that exponent. Or it's the base with this exponent is the number. The log of the base that gives us this number is this exponent. Okay, so the log is the exponent. That's why we say the logarithm is the exponent. We would rewrite this. If we were writing it as an exponential form, we would write this as the number is equal to the base with the exponent here. That's the way we would expect to see it, okay? And quite technically, what we should be thinking about is that L is the exponent. So we would really want to write it like this. N equals B to the L. The log of B for N equals L. Okay, that's kind of the way we need to put it together in our brains. So that being said, let's do a couple examples and illustrations to kind of flesh that out. So for instance, I could write 8 is equal to 2 to the third power. We understand this is so easy for us. We know this. 2 times 2 times 2 is 8, right? To rewrite that in logarithmic form, we would write the log of the base, which is 2, to get 8 is equal to 3. You see that? You see how that kind of comes together? The base that we use to get to 8 has to be multiplied by itself 3 times. So this is always the exponent, or what we call the logarithm. All right, so let's do a couple practice problems and put our brains in gear. So 26.1, we are asked to write the log of x to get 4 is m. We want to write that in exponential form. So 4 is the number, that's the answer. The base is x, and the exponent is m. That's it. That's all we're doing. Let's try another one. 26.2. We have the log, or actually it's the other way around. We have 4 is equal to 3 times y. We're going to write that in logarithmic form. The log of the base 3, which gives us 4, is equal to y. Booyah. Right there. Easy peasy. You guys can do this. It's not, you just take in the parts and rearranging them. Write this down. Okay? Write this down so that you have the format somewhere in your notebook, on the back cover preferably, so that you can see how the parts go together. That's what we've got to do. All right, we're going to try some more. So let me clear the page. We're going to 26.3. We can actually solve some of these, believe it or not. We're going to solve the log of b that gives us 8 is equal to 3. You guys can probably already see this in your head. So 8 is equal to the base b with an exponent of 3. So we have to solve for b. So what do we do when we want to factor something here? Well, with an exponent, we do this little index jobby right there. We do it to one side, we do it to the other side. This cancels. So the cubed root, or the third index of 8, is going to be 2 is equal to b. Just like that. Not a problem. Right? We know how to do that. That's not that big of a deal. Let's do 26.4. That's not that hard either. So 26.4 says that the log of b, which gives us 9, is equal to -1/2. Not super hard. We're just going to rewrite it in the exponential form that we understand. So 9 is the answer. The base is b, and the exponent is 1/2, -1/2. So what we're going to do to get rid of this exponent here, we know we can multiply exponents in order to change them around, but whatever we do to one side, we have to do the other side, right? So we're going to multiply this by -2/1. We're going to multiply it by the reciprocal so that we can get rid of it. We're going to do the same thing over here, only this on this side, I'm not going to put it over 1 because it's the same thing as -2. It just makes it a little bit easier to solve. So that gives me 9 to the -2 is equal to b, because these two cancel. And a negative times a negative is a positive. So now I just have to reformat this. 1/9 squared would be 81. So that is the value of b. That's what my answer is. I could also write it as log of 1/81. That gives us 9 is equal to -1/2. But that's a solution, okay? This is what b is. So this is more than likely going to be the answer I'm looking for in Jupyter. All right, so let's look at solving another one. Let's do 26.5. We just have a few more of these. 26.5 is the log of 3, that's our base, that gives us 1/27 is m. So let's rewrite that in exponential form. 1/27 is the answer, the base is 3, and the exponent is m. So right away I see that this is 1/27, so that tells me that this is going to be a negative exponent. So because it's a negative exponent, I'm going to put this in a negative form. I'm going to flip it. So that gives me 1/27 is equal to 1/3 to the -m, right? Because I just flipped 3 to this m, I've got to change it to the negative form of that because we flipped it, right? Don't forget to do that whenever you have to flip one of these. You have to remember that that's part of it. You can't just incorporate it into the m as part of the variable. It's a part of the process. So now I can eliminate this, right? I'm going to eliminate the 1/, and set 27 equal to 3 to the -m. In order to get rid of the -m, I'm going to do the whole -m thing here, -m thing here. This would cancel. So -m 27 equals 3. So my factor is 3, and I have to figure out how many times, what the index is to give me 27. Well, I know that, 3 times 3 times 3 is 27. So the index here for 27 that gives me 3, that is going to be -m is 3. That is going to be my m. Right? And my fingers are getting a little numb here from writing so much. But that is how we would solve for that. My index is going to be a negative. It's 3, but it's a -3. That is my equal m. Because if I had said, all right, let me go a little bit long way around. If I had said -m is equal to 3, because that is the index right here, right? 3 times 3 times 3, we got 3 here. That's the index of 3. So m is equal to 3. Negative m is equal to 3. We don't do negatives right here. We don't do a negative variable. So we multiply both by negative 1. So m is equal to negative 3. That's how we get there. All right. So that's the answer. 26.6. Let's do one more. So we have the log of 1/3. The base of 1/3 that gets us to p. So now we have like, there's our number is the variable, is -2. So remember, on the first one that we solved, we had the base. The base was the thing we solved for. And then again on the second one, the base was the thing we solved for. Now on this one, we solved for the exponent. Now we're solving for the number. So these are example problems that you need to write down what's going on. This is how to solve for the exponent here, right? The previous ones were solving for the base. This one is solving for the number. This is the example you used to solve for the number. So now let's rewrite this in exponential form so that we know what we're doing. So p is equal to 1/3 with the exponent of -2. All right. So the first thing we do is we multiply and apply that exponent to each of these, or to this part right here. So it's going to be p is equal to 1/3 to the -2. And when we flip this, p is equal to 3 squared. So p is equal to 9. So we simplified that basically. We just simplified it. And the reason the 1 remained the same is because it doesn't matter what exponent 1 has. 1 is always 1. Even if it's a negative exponent, if you give 1 a -2 and you flip it, it's still going to be the same. So we applied the -2 here, but it still becomes the same thing, right? It just stays 1 because 1/1 is always still 1. So you can apply at any exponent that's -1 and it's going to remain the same. But we applied the exponent -2 to the 3 and that caused us to flip the fraction. All right, so there's some logic there to follow through. So let's look at number 26.7, just to keep practicing and wrapping our heads around this exponential logarithmic correlation. We have to solve the log of 4 that gives us 8 is x. So we're solving for x. So we are going to rewrite this. The answer is 8. The base is 4. The exponent is x. All right, so we've got that rewritten. Now this contrived problem can be solved if we see that we can actually rewrite this here. So 8 is equal to 2 times 2x. 2 to the 2x. So we have to break this down. And then we need to break this down too so that we can solve for this. So we want to get the same base. We want the bases to equal. So we have, this is going to be 2 cubed is equal to 2x. So now that your bases are equal, remember those denominator problems where those equations where we would get the denominators to be the same? So like if we had 3/2 plus 3x/2 equals 7/2, we could just, multiply everything by 2 and it would eliminate all the denominators, and then that would leave us with 3 plus 3x equals 7. Remember when we used to do that? We're going to do that here. That's exactly what we're going to do here. We're going to eliminate the base. So what we have is 3 is equal to 2x. So we're going to divide both sides by 2, and 3 over 2 is the value of x. That is our exponent. So the log of 4 that gives us 8 is equal to 3 over 2. But this is the answer that we would put into Jupyter. The 3 over 2, not the x. I guess I should clarify that for future users of these videos, that this is what we would put into the Jupyter system, not the equal x. We don't ever use that. We just put in the answer. So part of the whole process is understanding the relationship between the numbers and how we can resolve that. That's what all of this math stuff that we're learning is all about. It's understanding the relationship of the numbers to one another and how we can find some commonalities and build relationships to solve for what we don't know. I mean, that's the whole thing that we're doing in all of this math. And we're just pushing through it. So remember this type of a thing when you have two numbers that you can't possibly solve this in your head. Like you don't know what exponent of 4 could possibly give you 8. You know 4 squared is 16. You know that can't be a thing. You know it can't be 2. So start with 2, right? Square this number. And if it doesn't equal this, or if it's greater than this, you know you need to bring it down and try to find this with an exponent to put with this number here. All right, that's your clue. Go 4 squared is 16. Oh, nope, that can't even be a 2. So I must have to reduce this some way. So then you start looking, can I square it? Can I cube it? What can I do to get this down to its prime factor, or to a factor that is then relatable to this number? And we know that 2 is a factor of 8, that we can cube 8, right? And have a 2 here and have a 2 here. That allows us to then simplify further by eliminating the bases and solving for x by just solving the exponents. Right? Okay. That's all I have for lesson 27. I'm sorry, lesson 26. Man, I'm getting ahead of myself. If you have any questions, please ask. It is a lot to wrap your head around, but I think that this lesson did a pretty good job of breaking it down and giving us lots of practice to see the different types of problems. This type of problem would be one where we have to reduce the base. Okay, or the other word is factor. Probably actually the better word for this would be where we have to factor the base. All right, so be sure to put that little note out there beside this problem. All right, that is all I have for lesson 26. I will see you in lesson 27.